Hi everyone, this is Abhay from V45. I'm really pleased to present this demo of ThreatPlaybook. I hope you get to use it. I hope you find value using it. So let's get started with how it works. So this is the example that is given to you in the documentation as well as in the GitHub repo. The example is essentially a list of folders as well as a robot script that you'll need to run. You can just look into the documentation and figure out how to run it and all of that. Now, if you see this directory or the set of directories, you have a bunch of files. Now, these are the user stories, abuser stories, and threat models for different user stories. So each user story is captured, or each functionality. We use user stories loosely, but if you want, you can call it functionality definition or whatever it is, and it is captured as individual YAML file. So if you open this, you'll see that this is the title of that particular user story. It has a description, it has a bunch of abuser stories, and each abuser story has a bunch of threat scenarios depending upon. Of course, this is an example, so I'm not putting too many threat scenarios, just a few to get started and to give you guys an idea of how it works. Now, you don't necessarily have to always use the abuse cases header for all of this. You can directly use the threat models here, or the threat scenarios here. You don't necessarily have to use abuse cases all the time, right? And so you essentially document the threat scenarios with a particular title, description, a dread score. So dread is essentially damage, reproducibility, exploitability, affected users, and discoverability. So you can enter dread values. I've entered some dread values here. I probably need to finish entering it, so I'm just going to enter some values. This is comma separated. Please make sure there's no spaces between after the commas. The other thing that you can use is the CWE. Now, one of the things that the reason why we use CWE here is because when you run your vulnerability tests in a completely automated fashion, what happens is that a lot of tools typically have CWE values, right? So you can, as soon as the CWE values are identified here against what they found in the vulnerability results, the tool would try and map these two and try and figure out which vulnerability results actually link to which threat scenarios and threat cases, right? So you have the CWE for additional correlation. You can have multiple CWEs per threat scenario. So in this case, you see that we have two CWEs for this threat scenario, and in this case, we have multiple CWEs for this particular threat scenario. You also have the cases. Now, the cases are linked to the security test cases, which I want to get to in a little bit. This is the unique header for that particular each security test case that it's linked to. So you can just create a document like this, and you can keep adding on. The idea is that you create a spec style or a playbook style document here, and this keeps getting added, and you can check it into your repo and keep adding, removing from it whenever as required. So the security test cases are documented here. So these may be a list of cases that you want to run. These necessarily, it's not that these are run or these are not automatically run. It's just that these are a list of test cases that you want to run against that particular application or against that particular environment. So each of the test cases have three values. So one of it is the header, which has to be unique, and it has to have it should not have spaces. You need to use underscore whatever in order to keep the values unique. You have descriptions. You have a description of what the test case is all about. The three types essentially: automated, manual, and recon. And you have tags. Now, what happens is later on the tool also links to the security test cases by tag. Now, this functionality has not been fully implemented in this pre-release version, but it's going to be implemented soon. So you see that a lot of these have multiple tags. So some of these are manual, some of these are automated, whatever it is. So you have different security test cases. You also have entities. Now, these are the entities that uh, you would be using to generate the process flow diagram, which is going to be used for your threat modeling piece. Um, right now, we are not using the entities beyond just the diagram creation. So we're not using it beyond creating just the diagram. But later on, what we want to do is start linking these entities back to the threat scenarios and threat models, and then have a more complete perspective from entity right over to the vulnerability assessment results and so on. So here, each of the entities, again, these names need to be unique here. And you have a description, a caption, a name. All of this is given in the documentation you can go over. And these entities are connected to each other. So what's going to happen is at the end of this, if you create connections, what's going to happen is that it's going to generate a process flow diagram based on the connections here. So this is the start node, this is the end node, and this is the data that's being exchanged between the entity, the start entity, and the end entity. So in this case, user logs in to the login system with a username and password or login, and then you go from there to search with customer PII, so on and so forth. So you have all of these connections documented as well. So with that, let's quickly look at the script that runs everything, the automation that runs everything, right? So I'm gonna quickly open it up here, and you see that this automation or this automation script is running a bunch of things. So first of all, it's going to be running the threat modeling. It's going to run all the threat modeling cases that you've documented here. It's going to run, identify the entities. It's going to identify the security tests, and it would store that in a MongoDB. You need MongoDB for this, so please install MongoDB and run it. So this is the threat playbook, and it initializes with a customer API. This is the project name, so you can initialize it with any project name of your choice. This needs to be a unique value. You have collections, you have, it also runs Zap. This automation script runs OWASP Zap, and OWASP Zap is running at port 8090. It also runs Nmap. It also runs WFuzz, which is a generic fuzzing framework in Python. It runs a REST library. The idea of running the REST library is to authenticate to the REST API. What we are doing with this particular test automation script is authenticating to a REST API, proxying all the while through Zap so that we don't have to spider through Zap. So we're authenticating it with the REST API, running a bunch of functions, and then scanning those REST API functions with Zap, right? So this is how we're going to be doing it. All of these are variables that you can set. These are relatively simple. They're quite self-explanatory. You need to probably change some of these variables and these paths, obviously, depending upon how you want to do it. So these variables, zap, the location of zap.sh needs to be given. Flask API, this is the name of the app. What is the format you want to store it in? Report author. You need some of these things to generate the Zap JSON report. So that's what we're doing. Now, the rest of the stuff that you're looking at are the test cases, right? Each of these are run module by module, and you will find that they either pass or fail. So if they run correctly, they pass. If they don't, they fail. They fail for a particular reason, and they'll tell you why they failed. So this is how robot framework works. So if you can look at robot framework, you want to learn more about robot framework, you can go to robotframework.org and learn about how it works. In this case, what we're doing is managing the entities, generating the threat models. We're creating a particular target, which is our application. Now, this application runs in a Docker container inside my host operating system. Right now, this is just a simple web API, REST API with which runs a Flask REST API. It has a bunch of 4 or 5 functions. It's rather simple to use, but you can run it against any application. You just need to specify that application and run it. So what we're doing is we're going to do a port scan first. And once we do a port scan, it generates some results and links it back to our results. Then we run directory brute force with wfuzz. Now, one of the things you'd notice that it only runs for 2 minutes. Now, let's actually reduce this because we're just doing a demo. Let's run it for 30 seconds instead. And as soon as it times out after 30 seconds, it fails that test. Now, it's fine in this case because it's a directory brute force attack. But if you want to run a directory brute force for a really long time, you can set a timeout and it would adhere to that timeout and just stop after that particular time. Then you have brute force results, which is linked. Then you start Zap. Now Zap starts up. It starts up in GUI mode. You do have a headless mode that I've provided in the Zap robot API as well. You can run it headlessly. So in fact, all of this can be run in a CI/CD pipeline rather easily, right? It's just about running a simple script, and it'll run in a CI/CD pipeline quite well, actually. Authenticate. It authenticates to the web service all the while using Zap as the proxy, as you can see. So it sets it. There's a JWT token which you get post authentication, which you need to use in the rest of the queries or rest of the functions. So the token is set in each of these functions. It's a really nice REST testing API which you can use. I am using this for robot framework, but you can use it as well. Then once that is done, Zap starts its active scan, it generates a report and shuts down. After that, Zap results are parsed into the database, and we have a very interesting new feature called threat maps. Once all of this is done, it generates a threat map, and you can see a threat map is essentially a link between user story, an abuser story, or an abuse case, threat scenarios, and the test cases. So it kind of gives you a whole perspective of these four entities in the in a diagram kind of a fashion. So it kind of is very nice for you to use it in terms of how it can work, and the visualization is quite interesting. So a threat map is generated and it creates a final report, which is a markdown report. And once it's done, it shuts down the script and that's it. So it's really that simple. So think of this like a recipe, right? Or a playbook that you would use to run. So all you have to do is create this playbook and you could use it in a sprint, you could use it for an entire app, you could use it iteratively, however you would like it, and you could run a bunch of tools. Then, so in this case, we're running three tools. We're running Zap, Nmap, and WFS, but you could run Burp or you could run whatever it is. As long as it has a library that supports robot framework, and we are coming up with a lot more libraries as well, you can run an entire pen test or at least a vulnerability assessment with a great degree of automation and parameterized automation with just this playbook concept, right? And it also, since it supports threat models, you're kind of going from the threat modeling bit right down to the way you can run a vulnerability assessment that link to the threat model. So let's run this without discussing further. Let's actually run the script. I'm going to kind of fast forward through some of the sections that are a little time consuming for everyone's benefit. I don't want you staring at a um, screen for too long. So let's run it. As you can see, it started running. It has started loading the test cases, the threat models. It's creating the targets. It's done a port scan. I've done a very basic port scan. I'm not really spent too much time running a very detailed port scan. The directory brute force should stop within 30 seconds, and it should show that it's timed out in 30 seconds. Uh, it, uh, it is typically, since we scheduled it to run only for 30 seconds and stop after that, it does that and typically times out. It gives you a failed result because it's timed out, but that shouldn't matter because directory brute forces take a really long time. So then, as you can see, Zap is initialized now. So Zap starts up, and this is, as you can see, all of this is completely automated. Zap starts, then the authentication of the REST API should really start happening now. So it accesses the REST API, and you can start seeing some activity in Zap soon. The REST API starts up, and then authentication happens. It fetches the few functions, all of those work, and then it should start the Zap active scan. And as you can see, Zap active scan started. It's already identifying a bunch of results here. Um, I am running a very lightweight scan policy in Zap because for the demo I didn't want it to run forever and ever. So it I'm running a lightweight scan policy, but even with that lightweight scan policy, it's able to find a bunch of it. The reason we can do this is because it parameterizes, right? You're not spidering with Zap, especially with a lot of applications today where you have like Angular or you have a complex front end, you can't really spider too well. Or if you're testing REST API, you can't spider at all. So that's where you need to run security scanning services or vulnerability scanning services with a test automation backend so that it passes through the vulnerability scan and gives you a better quality of result. So you can see that we've already found a bunch of stuff with cross-site scripting. We've found a bunch of other errors. I'm going to kind of run through this rather quickly. As you can see, all of the time, this status is maintained. The state is maintained by Zap's API. Zap is one of the tools that provides a great API that allows you to maintain state or a status of the running scan. I'm just going to kind of fast forward through all of this. And once the Zap scan is done, which it is, it's going to shut down, and then it's going to write all of these results. It's going to write them to the MongoDB database first, and then it's going to write it into the report. So Zap shuts down soon, and once Zap shuts down, it generates all of those threat maps with Mermaid.js. You need to install Mermaid.js for that, and once it's done, it's all that you're set. All your results are done. So you can see the all of the results are stored in the results directory here. In fact, your diagrams, your reports, your threat maps, all of these are stored here. Um, you can see some of the threat maps. So this is kind of like a diagrammatic representation of the user story, the abuser story, the threat scenario, as well as the security test cases for that threat scenario. And all of those are captured here as well as in this diagram. So it depends on the complexity of the diagram and the kind of interactions you have between each of these elements, but it's a useful view to see. And if you want to really think about it, if you want to think about it in a big perspective, you can really think about this using some of these threat maps feature by feature. This also facilitates iterative threat modeling. That's one of the things that you need to understand is that we need to threat model iteratively. This is probably a great framework to do it in because it allows you to do that iterative threat model. Then it also generates the Markdown report. Now, the Markdown report has not only a diagram that it generates from the entities and connections that you otherwise define. Let me just increase the size of this. It creates a list of the threat models that you've captured in that particular. Now, all of this works in find or create mode. So unless there is a change in your existing spec, it's not going to duplicate the threat model or duplicate the security test or the abuser story or so on and so forth. So you don't have to worry about duplicating results. The only thing that it does duplicate is the vulnerability, but that is linked to a particular session, and only the vulnerabilities for that particular run that you've done comes up in the results and doesn't duplicate again and again as well. So here you see all of the um, test cases, the user stories, the abuse cases, as well as the threat models. All of the threat models are detailed here as well, with the average dread score. In this case, the dread score is 8. In some cases, the dread score is 10. You look at different types of models here. And then you also have a list of vulnerabilities. Of course, we ran Zap, so we have a list of vulnerabilities. You do have injections and some of the other flaws that we've identified. And it also captures the linked threat models. Now, based on the CWE here, you also get a list of linked threat models. So if the CWE here matches what you've given in the threat model, it will kind of automatically correlate all of that stuff and give you some interesting information. So if you want to know what is your coverage as per your threat model, so if you want to know what is the coverage for your pen test or your vulnerability assessment against your threat model, this is a pretty good way of doing that. And this is an initial approach for us to do that. Of course, this is what Zap gives you as results. As you can see, it captures all of that. HTTP only, for instance, it's captured link threat models. You can do session hijacking, so on and so forth. So it also captures the Nmap results. It gives you a list of Nmap results and the directory brute forcing results as well. So that's it. That's it for this quick demo of ThreatPlaybook. I really would love feedback. We all of us would love feedback and understand what it is that we're doing right, what we could do. Obviously, this is not the only way that you could do a threat model, or this is not the best way you could do a threat model. Just one of the things that we thought would make a lot of difference to people who are already doing threat modeling, who want to use threat modeling in a more action oriented way rather than just storing them as documents and so on. So, this is what we have. Please feel free to reach out to me, follow me on Twitter, follow We45 on Twitter. We keep releasing a bunch of tools all the time. Most of it is available to the community, free and open source. Again, I'm happy to do this. Thank you so much for your time, and I hope you find value using ThreatPlaybook. Thank you.